Today we're going to do an introduction to exponential functions. So let's start with the definition. An exponential function can be written in the form f of x is b to the x, where b is greater than 0 and it can't be equal to 1. So let's talk about what's happened here. We moved x to the exponent and we made b the base, and this b is a fixed number, so b could be anything. It can be a whole number, it could be a decimal, it can be a fraction. We just have these two restrictions that it can't be negative or 0, and it can't also be 1, because 1 to every power is just 1, and then we wouldn't really have anything going on there. So let's start by just evaluating some functions and see how this works. What I'm really thinking is you're using your calculator, so make sure you are finding that button that kind of looks like an exponent. So it might be an x to the n, it could be a y to the x, or it could just be like an up arrow to say, hey, I'm going up to the exponent. So to try that, I said let's start with this function f of x is 3 to the x, and we are going to find f of 2, f of 4, f of -1, f of -3, and f of 0. So these are just the exponents we are separately going to put in. So I start with 2. So f of 2 is just 3 to the power 2, which we know is 9. Same thing, I'm putting in 4. So again, using the calculator, 3 to the 4th power, it gives me 81. F to the -1. Now remember, when we do negative exponents, that turns it into fractions. So that 3 to the -1 says I'm going to take 3 and I'm going to put it in the denominator, so I have 1/3. So same thing's going to happen when I move to -3, that I'm going to have 3 cubed, which is 27, in the denominator of my exponent. And then just one more, 3 to the 0. If you don't remember, good times to think about it again, that 3 to the 0 is 1. And that's going to be true for everything. So anything I give you b to the 0, it's going to be 1 for any number that we talk about in this section. So I hope that you're not just listening to me, I hope that you're also trying this. Remember, because it's a video, you can stop it if you need to. If I'm going too fast, just stop it so you can slow me down and you can try these values. I do know that when you put these into your calculator, it might give you decimals instead of fractions. So remember to click it back over and turn it into a fraction, because a fraction is more accurate. Having 0.33333 feels like the same thing as 1/3, but I'd really rather see 1/3. So we should try this again, and I want to give us a different look. So I said, what if we do 1/2 to the x? So again, I want to go through and just pick a couple of different values. So I picked 5, -5, 2, -2, and 0. So let's start with this 5. I want you to see that there really are parentheses here. Maybe it doesn't look like it in the way I did it, but we really want it to be that it's 1/2 to the x. So I put 1/2 to the 5th. You can put it in your calculator. If you do that, make sure you use parentheses like I wrote it. Or you can separately think that 5 goes to the top and to the bottom, so to the numerator and denominator. So I did 1 to the 5th, which is 1, and 2 to the 5th, again with your calculator, gives you 32. So you decide which way is better for you. Is it better to do the numerator, then do the denominator, or do you want to put it all in at once? And again, fractions, not decimals, as answers. All right, so I wanted to see what happens if I put in -5. All right, so this -5, since I have a negative, it is going to flip my fraction over. So instead of having 1/2, it's going to flip over to 2/1. That way I can say 2/1 is just 2, 2 to the 5th is 32. Again, your calculator will do this for you, so if you don't like this negative exponent thing, don't worry about it. Plug it in your calculator, see what you get out. Let's try it again. Let's put in just the number 2. So 1/2 squared means I have 1 squared, which is 1, over 2 squared, which is 4. Same thing with -2, just to compare the two. So I did pick 5 and -5 on purpose, 2 and -2 on purpose, so they're kind of like pairs. F of -2 being 1/2 to the -2 says, once again, I'm going to flip that over. So instead of 1/2, I have 2/1. I know 2/1 is 2, so 2 squared is 4. And I'm just going to keep pushing this at you that f of 0 will be 1/2 to the 0, which is just 1. All right. I wanted to quickly say, remember order of operations. If I give you a number in front of our exponential, so I just wrote given f of x is a times b to the x, just to say I have some number in front. I always do exponents before I do multiplication. So let's look at that in a few examples. So look at, I have f of x is 5 times 6 to the x, and I would like to put in 3. So putting in 3, I have 5 times 6 cubed. I'm showing you that 6 cubed is 216, so 5 times 216 is 1080. You should be able to put this in your calculator as one big expression. So it will be important that you try this, right? Don't just take my word for it. Give it a try. See how your calculator works, because some calculators are different and I want to make sure you're getting the right answer. I also want you to see this is not the same thing as doing 5 times 6 is 30 and then doing 30 to the power 3. I'll quickly put it in my calculator. 30 to the power 3 is 27,000. That's much bigger than the 1,080 we got. So I wanted you to see, make sure we do this order of operations as we go through and make exponential functions bigger. Why that's important is because these are used a lot in the real world. So I wanted to give you a couple of quick applications. The first one, I thought, let's do something positive, which would be an investment. So say we have the value of a stock can be modeled by the function v of t is 35 times 1.08 to the t. T models the number of years after 2015. So we're assuming we bought this in 2015 and it only went up. Great investment, right? So let's see what would happen. So let's start with finding the value of the stock in 2018. With the application, we have to pay attention to the fact that my time is the number of years after 2015. So I have 3 years have passed. I'm going to put in 3. So I have 35 times 1.08 cubed. Because this is money, I did round this to 2 decimal places, right? So just down to cents. So I hit in 35 times 1.08 cubed, and I got 44.09. Let's look at what happened by 2020. Again, I start by saying how much time has passed, which would be 5 years, and I put in 5. So I have 35 times 1.08 to the 5th, which is $51.43. So here is the upswing. Let's look at the downswing. So the downswing as an application here could be buying a car. So it's kind of an investment. So we're going to say the value of a car t years after it was purchased can be modeled by the function v of t is 28,000 times 8.5 to the t. We're going to start just by thinking, how much did we pay for this car? So that would be at time 0 when we purchase, we would get 28,000 times 0.85 to the 0, but we know 0.85 to the 0 is 1, so 28,000 would be the original purchase price. Let's look at what happens 2 years later, which is v of 2. I had my 28,000, I have 0.85 squared, so now the value of the car is 20,230. So car value generally is going down. This one went down about $8,000. Let's look a little bit farther in the future to 6 years. So now I have v of 6 is 28,000 times 0.85 to the 6, which is $10,560.18. So big change from the $28,000 that we bought it at. One more thing I want to talk about before I finish this video is the number e. So we're going to use this special number e, and I want you to find it on your calculator. It will probably appear as e to the x, so I took a couple of shots of calculators I have, so that hopefully you have one of these. So this is the TI-30XA, and you see how this e to the x is over this ln button, so you're going to have to hit the second to get to it. I have it here on the TI-30X2S, and again over the ln button. And then one more, oh, I thought I had it in there. Let's see if I did. I thought I had also, oh, there it is, out of order. This is the TI-84. I just do happen to own only TIs, but again, over the LN button. So in each of the calculators, this e to the x is there. So I'm gonna have to hit that e to the x button to evaluate things. All right, so going backwards, I want to use this e to the x and find a few values. So I thought, let's get 1, 2, 4, -3, and 0. So putting in 1 gives me the value of e. It is not going to ever have a pretty decimal place, no matter what number you put in there, well, except 0. Spoiler alert, that's one of the questions. So I decided this time, let's look at 5 decimal places. So I put in 1, I got 2.71828. Right. Don't be fooled that 828 doesn't mean there's a repetition. It goes on forever. It's a very interesting number, and we will talk more about it in the future. Today, I just want to start playing with it. So let's look at squared. Squared gives me 7.38906. Again, I rounded. To the fourth, 54,000. Wouldn't that be nice? Just 54.59815. All right. Throw a negative just to see how it differs, and it becomes smaller. So positive is going up, negative is going down for this one. I get 0.04979. Do you notice, no matter what, if I put in a positive or a negative, I always get a positive outcome. The size of the number changes, but the answer is always positive. And just this last one, let's plug in 0 because 0 is always interesting, and it gives me 1.